Well, I've got to be careful what I say now. Okay. Okay, so yeah, I'll just go through a bunch of steps. The first one was opening up OMFIT. Like I said, I'm running this on Portal right now, but it's you can do it from your desktop. It doesn't really matter. But then the first step, once you have OMFIT up and running, is to import the M3Dc1 module. So I go to File, Import Module, and it starts looking up what various modules are available. So it's searching both the main OMFIT branch and my own personal OMFIT version. And so this is loading it from the main OMFIT branch. And if I can search for M3Dc1, and then I load it in, take a moment just to get everything loaded, but it's pretty quick. Okay, so now this here on the left is the OMFIT tree. It has everything that's loaded into it, so you can load other modules in. For example, one could think about doing a kinetic EFIT, having that loaded in, and then automatically connecting it to the M3Dc1 module to automate that. But here we're just going to start. So there's, if I look at what inside M3Dc1, there's an Inputs tab, which is waiting for profiles in and out, but it's not there yet. There's a run auto C1 script and an extract profiles script, but the main show is in the GUIs. There's a GUI auto C1. And I'm going to just move this up real quick. Do the same with this. Yeah. Okay. So if I double click on GUI auto C1, this little interface appears. And right now everything is empty. So we can talk about this more if you're during a tutorial, but one would also have to set up eventually the remote server connections so that it could run properly on Portal R6. But again, we can talk about that more later. So I'm just going to change this. So there's three different tabs here. There's a Setup Equilibrium tab. So this is where you pick your equilibrium files. There's an Extend Profiles tab, which allows you to extend the profiles beyond the separatrix, which is an important part of the normal M3Dc1 setup. And then you can select what kind of calculations you want to do. So we'll go through these in order. So I'm going to do a D3D run. So you can select right now between D3D and ASDEX. We could extend that to NSTXU or anything else we want as well, as long as there's interest. And I'm just going to change the run ID to demo. So now I need to pick a G file. And so you can do it if you have one locally. If you have it in the tree from another run, you could get it from there.
What does remote mean? Remote mean you go to some place out to pick.
Yeah, so I'll do it remotely. I'm gonna do it. Look for something on Portal, and it's going to be. Let's see if I can do it from memory. TSC/B-lines. Templates /BD/G3/G1530/13796. This works first try, but it'll be a miracle.
Right now, do you have to type in the whole name, or can you just grab it from the text?
If it's on the local terminal, then you can go through the directory structure and get it. If it's remote, though, you have to know what the address is. Yeah. So that worked. I was able to get the G file, and you can see in inputs over here now, the G file has been loaded into the tree. So now I'm going to do the same thing for the A file. And you can see if I've done something from the remote server already, it already has that folder available. I'm just going to replace it anyway because I can just change one letter. So we load in the A file. Okay, and now I have to select the profile type. So I can put in a P file. I have options right now for P files, and these Morgan Schaefer has these M3Dc1 profile types. Those are what's available for D through D. If I were to change this to ASDEX, then there's this ASDEX structure you can choose from there. But these are these profile types I could add more to later for sure. But we're going to take a P file, and I'm going to do remote and change this to P. Okay, so now we've got an A file, a G file, and in profiles in, I have a P file loaded as well.
Can you double click on the G file just to see it?
Sure. Just double click?
Yeah.
So, okay. Or so, go ahead. You know more about this
than
me?
No. Just it looks like a kinetic key fit. You have a nice pedestal. I can see that.
A nice structure, yeah.
Yeah, bootstrap current. Yeah.
So that's a feature right there. When I double clicked on GEQDISC, that it's just built into OMFIT already. It knows what to do with that. When you double click on it, it runs a script.
And it will be the same also with the P file. If you double click on the P file, it'll know how to plot itself.
It's going to show me. Okay, yeah, so it shows me all the profiles.
I noticed the Q profile is negative. Yeah.
Where?
The previous graph is that you go back to GF with this safety factor on the right.
Yeah. So.
Oh yeah, so it's reverse IP or something. Okay. Just whatever convention they use, but great. So we've got all the profiles loaded in that we're going to use. We got all the equilibrium files that we need. So now the first thing I'm going to do is extract the profiles, and this is going to process the P file or whatever other files are in profiles in to get the input profiles that M3Dc1 uses. So when I click extract profiles, profiles out gets populated, and now I have a profile NE, TE, and profile omegas. That these are things that actually M3Dc1 would read in. Okay, so now I have all the input files in.
So what if you already have these? What if you already have the profile underscore any profiles? Is there any way of just loading those in?
So I could make that. I could put something into the GUI that would allow you to do that for sure. But the other option would be to you can populate this tree however you want on your own. So you could just load in profiles NE, TE, and profile omega into profiles out, and then this would work.
So you could do it manually, but probably, Brandon, one thing that you could do is select profile type should be just native M3Dc1, right?
Yeah, you could do that. Yeah, for sure. That's an easy thing to do too.
Yeah, and useful for.
I can.
Yeah.
Let me start making a list of changes. Yeah.
Very useful for people who already have M3Dc1 runs.
Yeah, exactly.
Mm-hmm.
You could probably also think of giving, another type of input could be an existing M3Dc1 directory, like run directory. I would think that you'll find all of the inputs already there. And let's say that you want to add a new calculation, you just point it to an existing M3Dc1 directory, load all the things that you need, and just continue. Just,
That's
some ideas.
Good idea too. Mm-hmm. Good idea as well. That's all easy. That would be easy to do. Okay, but assuming we've done all this here and we're working with new files and everything, the first thing now what we need to do is extend the profiles beyond the separatrix, because the data we assume is only given out to SciF1. So if I click on the Extend Profiles tab, this comes up, and right now I have options to extend the density, which would be the profile NE file, and the electron temperature file. And it has a few parameters. This is based on an IDL script that Nate had made a while ago to do the same kind of thing. You select the minimum value you want outside the separatrix. You select the minimum psi for the fit. You select the maximum size, so where you want to extend it to, and then an initial guess at a center and width of the fit. And then I've also included the smoothing function that if it's none, it's going to take the if it's none, it's going to take the input data that you got from the P file and it's just going to use that all the way out to 1, and then just use the extension past psi of 1. If I made this, say, psi of 0.98, it would smooth between the fit and the input data between psi of 0.98 and 1. Anyway, what I can do now, these are some initial guesses that are typical.
What's the width of the fit? What's you have a Gaussian or something?
So it's fitting the density and the electron temperature profiles to a linear tanh function.
Okay,
and so this is the width of the tanh and the center of the tanh. So if I click Extend Profile NE now, this figure pops up, and it shows me the orange is the actual data that was in the Profiles NE file to start. Blue is my fit. It's a good fit. It gets all the way down. It actually prints out in this little terminal over here. The minimum value got down to 0.11, and I wanted 0.1, so that's good. And so I can just click Accept Profile NE, and now it moves that blue profile into Profiles NE. Now I want to do the same thing for the electron temperature. And let's screw with it a little bit first. I'm going to make that 0.95 real quick. And if I click Extend Profile TE, I can see I get a warning. The minimum value went negative. And I can zoom in over here to take a look at what happened. And I just overshot. And the TE profile went negative. I don't want that. So instead, I'm going to go back here. I'm going to change this back to 0.9. And I'll hit Extend Profile TE again. And now it's good. The minimum value is 0.0001, which is what I wanted. If I zoom in, everything looks normal. And so I have a good fit now. So again, I can accept Profile TE extension. And now my Profile NE and TE are extended to psi of 0.1 at this really small value, which is what I want.
Is it assumption like assuming TI equal TE? That's why you only use TE here?
The assumption is that the pressure is going to be extended the same way the electron temperature was extended, and then the TI is whatever is needed to make NE times TE plus TI equal the pressure.
Okay.
So TI is not an input. It's not a free parameter of M3Dc1. It's whatever it needs to be to make the profiles work with the pressure profile.
The
okay.
OMFIT pressure profile.
So it's making the profiles from the P file compatible with the pressure profile from the G file.
Right. So the pressure comes from the G file.
Right. So the pressure is taken from the G file, right. And then NE and TE are taken from the.
But pressure of G file only exceed up to let's say equal to 1. So you go outside, you do the same fit.
Exactly. So outside, the pressure profile gets extended the same way that the TE profile got extended.
Yeah.
And so that can actually lead to rising ion temperatures in M3Dc1 in the edge, but we don't expect that to have a major impact on things. But that's all done inside of M3Dc1, so that's great. So now my setup is done. I have all the equilibrium files I need. This is what M3Dc1 is going to compute upon. So now I need to tell it what kind of calculations I want it to do.
Maybe, Brandon, maybe you can comment on the working directory of where you're going to submit the run.
Yeah, sure. So you can see that when I set up the equilibrium, I said the device was D3D. I gave it a run ID named demo, and then I loaded in a G file that had a certain G number, right? And then in my remote setup tree over here, I'm telling it the server I wanted to use is portal R6. And then the working directory is actually automatically generated from some of this information. So it has some base string that's a working directory I can use. And then it does machine, then the first number, so what's presumably the shot number of the G file, the time of the G file, and then whatever my run ID is. So I can do, if I want to do a new run, you just change the run ID and it's going to load it in there as well. You have to be careful because OMFIT will overwrite this directory. if it has write permissions. If I don't change the run ID and I do a new run, then it'll just wipe out the old one and put this in place. So right now it assumes that the user has some sort of directory named p/tsc/username. But if other,
actually,
if other users,
we modified that, right? So if we went
sort of, we didn't make it robust though, I don't think, but yeah. So if I look at the tree entry, I said Orson and I did this last night. If the person's PPPL username is in this long list of files that already exist inside folders that already exist inside of /p/tsc. So Nate, you're on here all the way at the end, I think.
This is a question for Nate. Right now, I don't have a portal. I don't have a Princeton computer account yet, but they wanted to do some testing of doing. Is it possible to get a PPPL portal 6 account?
Yeah.
What does it do?
I don't think that should be a problem.
Okay, yeah, I'll send you a request. You could help me to set it up. That would be good.
Yep.
Sure, yeah, I'll do that.
Yeah.
But if your username doesn't exist in here, so let's say Lang, you got an account, but they didn't give you a LWOW /p/tsc LWOW thing, then it would instead try to set it up from.
Basically, we'll go.
I don't know where you.
Basically, we'll go. So OMFIT has an area where users save their data. So instead of going into the location where usually the M3Dc1 data is stored, it will go under the area where the OMFIT projects are usually saved. So
okay.
You would
every OMFIT user has access to that.
Correct. So every user,
okay.
It's open. So Lang, you will still need a PPPL account to run on Portal, but you don't need to have to be a M3Dc1 developer or official user, let's say, to run M3Dc1.
Sure. So we did this with Orso last night. He didn't have this /p/tsc/Mangini. So he changed it to this, and he was able to run it properly through this. So, great. So again, we have everything's set up. So we just need to tell what calculations we want it to do. So I'm going to just reset the calculations here. So it's blank. It doesn't have anything that it wants it to do right now. You can do the same thing if I wanted to set up a new equilibrium. I can click reset setup, and it will erase everything from the tree that it had loaded in. But we'll go to select calculations, and there's 3 calculation types that we're allowed to choose from right now. We can do an equilibrium calculation, we can do a linear stability calculation, or we can do a linear time-independent 3D response calculation.
Equilibrium is 2D or 3D?
2D. So what it's doing, the equilibrium calculation, I can change the name of it if it makes more sense for people, but it's just computing the equilibrium on the M3Dc1 finite element mesh. So it's a higher order. It's taking the G file and then recomputing it onto the M3Dc1 mesh, the one that's been adapted. So it's going to be very highly packed towards the edge and such. Okay, so let's say I want to do an equilibrium calculation just for checking to make sure that everything looks good. So I'm going to add this calculation. I should probably change the name of that, but I add calculation, and it adds it down here. This left side is possible calculations I can run. The right side are the ones I actually am going to run. Okay, so now let's say I want to do linear stability calculation. Now it gives me options. I can give it a toroidal mode number, and I can select single or 2 fluid. So let's say I'm going to do n equals 2, and I want to do a 2 fluid stability calculation. So I click add calculation. Now it tells me I have a stability calculation n equals 2 fluid. And then I'm going to do a 3D response calculation, but for whatever reason I want to do n equals 3. Oops. There we go. and I want to do that 2 fluid as well, so I add that calculation. But now let's say I made a little mistake. I didn't want to do a 2 fluid stability calculation. I actually wanted to do a single fluid one. So what I can do is click on this. I can remove it. So it's still an option of runs I'm able to do, but it's not going to be run. And then I can go back up here and I can say I wanted to do a stability calculation that was n equals 2 and single fluid. And then I add that calculation and that gets staged there. But let's say these are going to get run, these are going to get submitted in order. And let's say it's more important for me to get the stability calculation done first. If the server was highly loaded, I can remove the 3D response calculations so that the stability one is fast and I can add it back. So you can reorder it that way. Okay, so now what this is saying is that I'm going to do a M3Dc1 run from scratch. It's going to run a equilibrium calculation, n equals 2 single fluid stability, n equals 3 2 fluid 3D response. That's what I want to do. Now I finally click run auto C1. So now what it's doing is it's running this run auto C1 script that I had over here. It's collecting some of these files that it needs, the profiles NET and omega, the G file, the A file. It's going to load all those into the this working directory down here, create a new folder called EFIT and put all that information into there. And then, let's see, it's connecting to the server and everything right now. Okay. So this is the actual script it wants to run. It loads up an S view so the user can monitor the progress of the jobs that are being submitted. So nothing's been submitted yet. There we go. So, Nate, are you doing this at the same time or something?
Yep, you just beat me.
That's good. That's good, Nate.
Yep. So it's running, and it's running, Nate, this M3Dc1 underscore EFIT is an IGS equals 0 calculation on the uniform mesh. And then the M3Dc1 EQ is an IGS equals, I think, 100 calculation on the uniform mesh. But you can see, if I go back over here, it's calculating EFIT equilibrium in unit EFIT, calculating equilibrium with M3Dc1 GS solver in unit equal. And so it's waiting for these to get done. We'll wait for it to get done because then I can show you. So it's working. You know, every things are running, and it's doing these. How long it take? This will take a couple minutes.
That's pretty fast.
But then to get to the calculations, that'll take an hour or something like that. But I just want to show one cool thing that this does. In the meantime, what I can show you is this is the script that's got submitted to Portal R6. And also helped me set it up last night so that it creates the environment that would allow this to run properly for any user. So as long as they have read privileges to some of my directories, which they should on Portal R6, then you can just load this in. It loads the path and everything properly. It loads the modules that we need for this, and then it actually runs the Python command down here on that script. So let me just see how I'm doing over here in SView. Still going. I think it takes 3 or 4 minutes, something like that. So what I can show you in the meantime is, so this is all being done in data OMFIT D3D158 6 in demo. So this is the folder that's been created by OMFIT to do this. The EFIT file folder has all the input equilibrium stuff. Current.dat, we didn't load in, but that got auto C1 automatically got that out of the A file using a shell script that Nate has written. If you're doing this on Azdex, they don't have A files, but they have these passive plates that have current in them that affect the equilibrium. Auto C1 will also launch IDL to calculate those currents and make a current.dat from that as well. So Auto C1 will automatically get the current.dat file from you either of those ways. If I look in UniEFIT, this one's finished already. I have a time 00, the H5 file out. That's the output file. So the EFIT equilibrium, that only takes 10 seconds to recompute on the mesh. And we're just waiting on this one to finish. Should be any moment.
So, Brandon, right now you focused on executing M3Dc1, and I guess the next step would be to maybe get some data into OMFIT just to do some, post-processing or visualization.
Mm-hmm. Yeah, and we have, as I'm going to show in a moment when this is done, I have Python post-processing scripts working now. Not everything that we usually do, but you can plot data. I haven't set it up to do flux surface averages yet, which is an important part of doing other detail calculations. I think also you wrote a flux surface averaging script a while back.
That works with M3Dc1,
So we need to make sure that that's still functional and working with the new, if any changes to M3Dc1. It's just taking longer than usual. I'm not sure why. It should be running no problem, though. Let me see. Yeah, it took about 5 minutes last night, so it's taking the same amount of time. So what I wanted to demonstrate was that right now there's just these script commands that M3Dc1 is running in this folder, but as soon as this is done, it should make a PDF that we can look at.
So say that you wanted to run it with some parameters that differ from your default setup. Like you wanted to change from even parity to odd parity, or change the viscosity or something like that. What's
sure.
Do that the way it's set up now?
So for the response calculations, I'm doing separate upper and lower calculations, so you wouldn't need to change even and odd parity. But if you wanted to change a parameter in C1 input, Auto C1 lets you do that. You can give it a directory of name and value, and it'll go through the C1 input name list, look for something with that name, and change it to the value that we had, that you want it to be. And if that parameter isn't in the name list, it'll add it to the C1 input file. Right now, I don't have it set up to be able to do that within this, but that's kind of my next step. Things is to let users be able to change the C1 input file from here.
So the C1 input file is just a standard Fortran name list, and OMFIT has some way of dealing with those, some standard way of dealing with those, right?
Correct.
Right. Yeah, it does. And so the idea I had was to have a kind of like a default C1 input name list that didn't have certain parameters set in it. and like only the one it would the auto C1 would only change the ones that it needs to change for these specific types of calculations.
Right.
And so it would just add in the values that it needs at the bottom or something as it goes through all this, and then within OMFIT you would just have like a C1 input default or something, and then the user could go in and change values there as well. But I haven't. So that's the vision I had for how to do it, but we could figure out a better way maybe as well.
Right.
Okay, so that run finished. So if I look in demo, uni equal, there should be an iter 1. So this is harking back to the days where we had to iterate on the equilibrium solution, but I just kept the structure. Okay, so it finished it. And then if I look in demo, I now have this equal check.pdf. So I wanted to be able to pop up a Python figure, and I've had trouble getting it to actually do that in OMFIT right now, but it still outputs the PDF, which is good. So if I do xpdf demo equal check, it's output a comparison between it's outputting some standard things that we check to make sure an M3Dc1 run is going well. So on the left, it's showing you the equilibrium shape for the EFIT and the equilibrium on the uniform mesh. And you can see between the black and the blue, it's getting a good match, the shape of the equilibrium, as good as we typically expect in M3Dc1. So that tells me that things are good. And then I have NE, TE, and TI plotted on some small scale, so I can just see if the values are going negative anywhere. So NE, it's not. TE, it is. I have all this noise outside, but just from experience, I know that if it looks like that, when it refines the mesh, that will go away. What I really care about is if TE or TI has a large, consistently negative area, that tells me that the input values have gone negative or something like that. So sometimes you see that if NE times TE is greater than the pressure, then TI goes negative, and you'll have an area around the separatrix where TI is consistently negative. And that would tell me, oops, something went wrong. I need to stop all this and figure out what happened. So I can, as an experienced M3Dc1 user, I can look at these files, these plots right here, and I can say, okay, I'm pretty sure everything's going well. I can let the calculation continue.
Quick question on equilibrium. Look at the external separatrix. There are a little bit difference there.
Yeah.
Do you know? Do you know what's due to?
That's pretty common.
Yeah.
I don't know specifically what it's due to, but there are a couple of possibilities. One is that we've changed the pressure profile from the EFIT by extending the profile, so it is a little bit different equilibrium. And the other is that we're doing feedback stabilization on a couple of the coil currents in order to keep it vertically stable during the Picard iterations. So both of those things can lead to small differences.
In the calculation, you're using all the current from the OMFIT coil and as well as the external coil. The current you're taking from the A file,
right?
And then you just adjust them slightly to keep vertical stabilization.
Right. Exactly.
I think probably the vertical stabilization changing a little bit, and near the separatrix, even small train can make some difference.
Yeah. So we do. It does feedback to keep the magnetic axis where it's supposed to be, but we don't do any feedback to keep the separatrix shape or something like that. Maybe somewhere down the line we could develop a more sophisticated means of doing that, but that's why we output this, because we want to make sure the shape is good enough in some sense, and it's kind of an eyeball test that we use. There's no real quantitative way that we define good enough.
There's no plasma current flowing in this SOL region.
There can be, because now because we've extended the pressure profile, so now you have a pressure gradient there, so you can support currents in the scrape-off layer as well. Those I've seen simulations where I've seen EFITs that we tried to use, and we get really big scrape-off layer currents because P prime and FF prime didn't get small enough at the edge or something. And that can cause problems. That can cause bad shape mismatches and things like that. But I've chosen an example here that I know works well and everything. But this is a good thing to. Anyway, so this was all done using Python post-processing routines based upon this Fusion.io FIO library that Nate has written that goes inside M3Dc1 and pulls this info out. And so I can do plots like this, and right now I just made it so that the scale was really small so that you could, I just want to see is it positive or negative anywhere. But you can use those Python routines to also look at the solutions later to look at how the n=2 structure is behaving. Anyway, I thought you'd like that feature, Nate. I think it's useful.
Yeah, absolutely.
Yeah, it looked pretty good.
But everything's running now. So if I go back over here, it said that it output the final error in the graduate final solution was about 1%, which is maybe a little high, but not anything atypical for what we work with. So I'm okay with that. And it's looking for output of certain files before it moves on to the next step. So before it moved on to doing an adaptive mesh solve, it looked for this time 0.h5 file, and then once it found it, it continued on to adapting the mesh, and this will take a while. So now I'm not going to sit around and wait for this to finish. I did this same exact setup and run last night, and I put it in a folder called done. So this was demo. Now I'm doing done. Same setup wasn't done. So now you can see that it adapted the mesh into this R1 adapt folder. It has it did the equilibrium calculation in R1 equal, RW1 equal, and then it has an n=2 folder in which it did a single fluid stability calculation, and it has an n=3 folder, in which it did upper and lower two fluid plasma response calculations. So now I already got this set up last night, hopefully. I can just use, I still, for the most part, use the IDL routines to do the post-processing just for convenience. But I can, just to see how everything is looking, I can do plot fields. So how did the upper I-call response calculation turn out? So it looks good. These are the fields from the upper I coils, and I'm getting something that looks like a reasonable plasma response. So that all looks great. And then I can do. I can double check the shape match on between the EFIT, the uniform mesh equilibrium, and the adapted mesh equilibrium. It shouldn't change, and it doesn't, as you'll see, but just for do that again with better colors. More slowly for some reason. There we go. So both of us, the blue and the red, are on top of each other, so you can't even see them. So we have the same equilibrium. I could check plot field. Whoops. But I was worried. Maybe you were worried about the electron temperature before. Was it still going negative in some places? How did I do this here? Sorry, one sec. So this is the electron temperature on a log Z. It doesn't look like it's not going negative anywhere. It's kind of minimizing out at 0.01, which is good. And then I also did the stability calculation. So let's look at the growth rate, for example. That doesn't look great. So something went wrong in the stability calculation, but it ran. I don't know precisely what it is. I think, Nate, it might be due to the. I think my default sequence input files have that discontinuity and the resistivity between the wall and the vacuum. So I might need to change my template so that doesn't happen anymore.
Maybe. I mean, that's not an obvious. It's not an obviously bad solution.
Right. So, but this is my point is that the runs I wanted to run were successful. You know, everything that I wanted to computed, and M3Dc1 ran properly. Now it's just a matter of figuring out if the runs I did gave me solutions that are consistent and good with what I want, and then I can go back in and right now you'd have to go back in by hand into those directories and start changing things if you want. I think Orso's idea is good that I should be able to load from an M3Dc1 directory. Maybe not even just get the equilibrium files, but I should probably set it up so that I can load it from a previous OMFIT auto C1 run. And so that if I want to do a new calculation, it doesn't have to go through all the setup again. It can just, I could go back to.
Right, especially because you're using auto C1, your directory structure is known, right? And I think you can take advantage of that.
Exactly. So I don't do that yet, but it's something that I certainly could do.
Right. And then in OMFIT, previously with M3Dc1, we only had the post-processing, and especially so this M3Dc1 file can be pretty large. So but if you're running on the same machine where if you're running OMFIT on the same machine where M3Dc1 is running, basically you have local access to those big files. And
correct,
and
yes.
You're storing the solution in this in this known directory structure. So I think it should be pretty easy. If OMFIT is running locally, to where the files are, it should be pretty easy to make the post processing, interactive.
Mm-hmm.
And then if the files are not local, then we have to think of how to do that. But I would start doing things for assuming that OMFIT and the M3Dc1 files are local.
Yeah, I think the proper way to do it if it was remote would be to be able to launch the Python scripts remotely. So give it the directory that you have, and then just go launch that Python script, make the plot that you want it to make, or get the data that you wanted it to get, and then extract it back. And then you could take that reduced data set. I shouldn't say data. You should take that reduced information and put it back on into the OMFIT tree.
That could be a strategy.
Yeah, I just don't think. I just don't think it's practical or even necessary to load all the H5 files onto the OMFIT tree. You'll have it's like a gigabyte per run. So
related to that, for regression tests, it's also useful to have some standard case that just load in run it, because there are a lot of
this one I'm showing you here would be the regression test. You just haven't defined the test yet.
I mean, there are a lot of development going in. Many times, the OMFIT may they may accidentally and intentionally break some of the length.
Yeah. Yep. So, Nate, I don't know if you have any comments. Do you think it's useful? Do you think it's something that you would use, or others would use, or is it overkill? What do you think?
I think it looks very useful. I definitely think it's something that people will use, especially as we get more and more users, and they're going to want something that's more user friendly than dealing with the Fortran name list and that kind of thing. And also, knowing what to look for is not obvious to a new user. So something that just presents people with what they need to see is very useful. So I'll be sure to show some of the newer users this capability.
Okay.
And actually, we might have you out here at some point as this gets more mature, to demonstrate this and train some people.
Sure. Yeah. And I could use your advice on improving the templates that I have. If you think some of the parameters I have are set improperly, there could be better ones better standard parameters, then that would be great. If there's other checks that you want me to output, like I have those equilibrium checks I showed you before, I can do that for sure. Yeah, I think this is, Orso was able to do this last night. So he's never used M3Dc1 before, and he wanted to make sure that other users would be able to. So he went through it, and without knowing much about M3Dc1 at all, he was able to get 3D response calculation running from the G files and everything.
No, I think it would be very useful. I'm not an experienced user, but I think when you're looking at it, I think particularly for right now, I think I think we are in a state where we encourage all experimentally to use. Many of them are very interested in learning, for linear run. So it would be very, very useful.
I think.
And I think this is the.
Yeah, the only thing that you're missing is the post processing, because last night I was able to run it, but then I'm left with an HDA5 file. So I think what I would suggest is let's put a little effort to get the most basic output, give it back to the user, and then organize a tutorial, and maybe just a few users, people who are already a bit familiar with M3Dc1, and then you can take their input and then grow from there.
So one thing, for example, that I could do is for certain kinds of runs have automatic post-processing run. So, for example, for a stability run, you're almost certainly going to want to know what the growth rate is, and what. So you could have it output a plot or a text file of the growth rate. Things like that.
The structure of the mode.
Oh, the structure of the mode, yeah. So I could have, when inside of Auto C1, it's doing these kind of things. I could have it so that it automatically, if I've selected to do a stability run, then it's going to output certain files, and then those could get loaded back into OMFIT.
Sure. No, I agree.
Right off the bat. I do agree, though, that something more interactive, so the user can select what kind of files he wants what kind of info he wants.
But don't get me. I think when I meant interactive is I click and I say show me the stability. Then I don't really care where it comes from. If it's a distilled information that is saved in a small file, that's totally fine.
Sure.
The example one, some of the other more parameters I would think of that I would like to change it would be the viscosity. Some viscosity, resistivity. Those.
Yeah, so that's all. That would all come from the being able to modify the C1 input file.
Yeah. It may not be the whole one, but some of the common ones.
Yeah, and in fact, what you might think of, one of the advantages of having an automated system like this is to do automatic scans of things. So maybe somehow we could hook this up with VeriPed or something like that to do scans similar to the way Elite is done.
Yeah, that would be pretty trivial, because with VeriPed you have a list of
once you can modify parameters.
Yeah. I think that would be nice. Submit it, and then after that generate phase stability diagram, phase space stability diagram.
Yeah.
Yeah, that'd be pretty crazy. So, yeah.
And also we could explore things that we've been meaning to explore but haven't because it's such a pain, like looking at the sensitivity of response to scans in viscosity and thermal conductivity and that kind of thing. This could be done sort of in an automated way to give us better uncertainty quantification.
Absolutely, yeah, I like the idea.
Yeah, the paper that I have to the journal now that varied the profile omega, that could have been done by making this profile omega as a list of profiles or something like that, and then OMFIT could have launched them all, simultaneously or something like that.
Yeah, so, exactly. So I think this is going to be where some of the big advantage of having this set up in OMFIT is going to be is doing these sort of automated scans, which is easy to do as it is now.
In addition, you also think of go one step further optimization, changing the equilibrium. Make some small change equilibrium. You can actually use dry fit to get the band or even M3Dc1 to for example, changing making small change elongation or triangularity. That would be interesting.
Yeah.
And then to
we have to learn how to do that, but yeah.
For example, I got talk about DMS. I got DMS system. I mean, how to adjust it to move away from the some subsubtly boundaries.
Sure.
Yeah, the EFIT module already has the ability to modify a G file, so you can perform parametric scans in in elongations or or other geometric, and you can scale the pressure and so on. So you can hook it up with with the M3Dc1 module and just loop over it.
The other thing that I think is promising is you could think about doing, if you had the right computing resources, some sort of inter-shot M3Dc1 analysis.
It is possible after inter-shot kinetic.
Yeah, because right now we're getting close to, if we don't have it yet, we're getting close to real-time kinetic EFITs.
Yeah.
And if we have those,
then shot, the first one probably between shot kinetic EFIT.
Yeah, between shot kinetic EFIT, and you could automatically launch an M3C1 run, and so maybe you need the right computing resources to get something done fast enough. Nate and I talked about being able to do low resolution M3DC1 solutions or something like that. But I think this provides you that capability because, like I said, if you're doing kinetic EFITs within OMFIT, which a lot of people do now, you could just automatically populate the M3DC1 PG and A files or whatever from that run that you just did.
Yeah.
And without any real knowledge of how M3DC1 works, you could launch something like this.
You just got to do a super manager to grab those.
Yep.
So
I think
is M3DC1 installed at NERSC? I would assume so, right?
Yes, it's there.
Okay, so it's I guess a matter of installing then the Python scripts that Brandon has on NERSC, right? Because really OMFIT for running is now interfacing to AutoC1.
Yeah.
And then and then it's just a matter of kind of changing the running environment for NERSC, just write it up into OMFIT, and then I guess the list of the calculations that are in that list on the right, you could expand it significantly.
Yeah, if you could launch a big variped scan as a single job and have it all done in parallel,
right?
That would be good.
Yeah, sure. And then so AutoC1 is also in GitHub separately, so you can download it for there, and it has instructions for how to set it up on your computer and everything. Nate, it might be good right now. This is all living in my own /p/tsc/blions directories. Maybe we could get this into the C1 directory instead, so that it's not going through my personal stuff.
Sure. Yeah, you've got access to the TSC directory, right? Yeah, your blions is there. So.
Right, but I don't think I have right. Do I have write permission to C1?
I don't know.
I would guess not.
I can get it to you if you need it. So I don't know if we have all of our stuff, all of the C1 stuff in that particular directory, actually.
Okay, well, maybe it doesn't need to be there necessarily, but we could even make a /p/tsc/auto C1 or something, but just someplace that's like less
a bit more
personal.
official.
Right.
A bit more official, yeah.
Right.
And then we could have that, and then you could do the same thing on NERSC or whatever. But and then we just need to, maybe come up with a more well-defined environment that needs to be set up for using it and everything. Because Orson and I kind of hacked this together last night for my own environment to just get it to work. But
I think for D3D probably the next thing to do local cluster so that experimentally, so not all of them have access to the portal.
So Auto C1 and M3Dc1 are installed on Iris already.
Okay.
With two caveats, and I have been using Auto C1 just as it's a Python script on Iris frequently. But they changed Iris recently, so that it uses Slurm instead of Torque.
Yeah.
Which is Slurm is what PPL uses. So I can I can show you like in come on. Equal batch start. So inside these directories, there's been a batch Slurm and a batch Torque, and depending on which computer you're on, it launched the proper script. So I haven't changed it on Iris yet, so that it launches the proper script. But that's simple enough. The other problem, though, is that they changed the cluster limits on Iris, which basically means that only a single a user can only launch a single M3Dc1 calculation at a time. Before, it wasn't quite so restrictive. So you could use it; it would just be slow.
We do have some, for theory, we do have some local our own cluster, Lohan 13, 14, and also there are two new ones which just arrived.
Okay.
So we do have them, and also I think
there's also drop.
Also some big ones.
Yeah, we had Nate and I had a meeting with Mark Kostick and maybe somebody else last year when we were, I think you were there, when we were talking about getting M3Dc1 and the GA clusters. Yeah. And they were very
helpful with that.
Very helpful, but very, they were very clear that they wanted us to be running on Iris. Yeah. That was their vision for the future of computing at GA. We talked about drop, and they they had little interest in getting us up and running on drop. I don't know about the Lohan clusters.
I think Lohan are very, very new. They all very new. I think 13, 14 are very new.
Do they use the same directory structure as?
No, not 13, 14. But the other one we just arrived a few weeks ago. That one we had the same structure.
Okay.
They're two. Yeah.
Okay, then if that's the case, then M3Dc1 should be able to run on that too. I guess my feeling on this is I'll put as much development time into this as is useful and desired. It's been a pet project of mine for the past year. But if it's going to be useful for other people to use, and there's other things that people want me to add to it, I'm happy to do it as long as.
You got an ambition. This one is tapped on a new side app. Side app with CTSS, CTTS.
Yeah.
Part of the could be part of that. Like what's that? Verification, validations.
Yep. This is something we could bring up tomorrow, Nate, in the meeting about UQ. That this capability could be developed further for doing a certain.
We want to prepare a view web. I think I would put go ahead, prepare a view web, bring it up. Because that I think the asking for I think this point would quite appropriate. So show it to other competition sites. Yeah.
Okay.
It would be quite useful.
Sure. Okay.
Excellent.
Great. Thanks a lot.
Of course. Thanks for sticking.
Well, we are going. We're going to have Christmas lunch in about half an hour.
Yeah. So it's one of those days where not a lot of work is going to get done.
It's the end of the year again, Nate. Yeah, end of the year, Christmas, Christmas lunch. This year we're going to Emerald Chinese.
Okay.
And we try a multi-course banquet like.
Wow. I think everyone here is out Christmas shopping. I don't know where everyone is today.
So I made a recording of this. I'll set it up and send it out so that people who are interested can see it.
Okay.
The other thing here, maybe I think you may, Ben, you might just to write up a highlight, send it to Alan. With the highlight.
Sure.
Yeah.
Yeah, this was
I
talked about during the ConeCamp that we went to.
It's okay for you, right, Nate? Ben is going to write a highlight.
Yeah, that would be great.
Yeah. One question I have for you, Nate, is given this will be living in OMFIT, there is a sense in which anyone that can use OMFIT can use M3Dc1 now. Is that okay? Do you want a completely unexperienced user to be able to use it, or should we have some sort of permission structure set up for how this works?
Well, that's a good question. I mean, so at some level, I'm okay with it, but I also see the danger in it that, people start just publishing paper. In principle, people could just start publishing papers, not really knowing what they're doing and using wrong settings and everything like that. So that's a good question.
Wrong citations and that kind of thing.
So what we can do, every module in OMFIT can have a license, and at the bottom of that license, what we can put is some emails, and so the user has to accept the license and to load the module, and once they accept the license, an email gets sent to the emails at the bottom of the license. So at least you would know.
Yeah, I saw emails somewhere in here.
No, it's not there. It's not there.
Yeah, you can go. Yeah.
So
you go one step further. Yeah.
Well, so that's the starting step. At least you would know who uses the module. Then there's also an error report. So if there is an error that occurs within the module, you'll get reports about what happened. We use it to help out users and kind of clear out bugs. But that will also tell you who's using it.
Right.
Sure. Yeah, I added my email address to the contacts within the module. I saw that. But,
right. So that's what
I think a license isn't a bad idea.
Not only that, I think OMFIT is used in a lot of places. China, Europe, many places. Set up.
And hold on. Also, people will still need access to M3Dc1. So they would need access to Portal or Edison. I mean, they would still they would need access to the M3Dc1 executable. Okay.
Sure.
So if you want to police that, you could restrict the access to the executable, for example, on Portal, to say only people who are in the C1 group, can actually run M3Dc1. Then automatically would
sure.
So there are ways.
Sure.
Right. Yeah. I'll think about what we might want to do there, and I'll raise this issue with other M3Dc1 developers, and we'll come up with a solution. I mean, in principle, we're okay with anyone running the code, but obviously we don't want people publishing bad results or anything like that.
Right. You can look at the license of GA code, and I can even send it to you. But there is wording for
yeah, I'm sure this is something that Jeff has thought a lot about.
Exactly. Yeah, everybody uses the gyro and so on, TJLF and so on.
Yeah. Okay. I just wanted to raise that because it's a blessing and a curse.
Also said that the D3D and XDX, they are sort of like a branded site license. Mm-hmm. In other words, all D3D users, they are allowed to generate just running DFID, running some others.
Right.
And then some away from I got you distributed site license and individual license. I got there's some compensated D3D and XDX, some big place. I got your branded site license that user can access them.
Mm-hmm. So.
Excellent.
Yeah. Great.
Okay.
Okay.
Okay. Thanks, Nate.
Enjoy
Okay.
the holiday lunch.
Thanks, Brandon, for I think it's very nice.
Okay, great. I'm glad people like it. I'll keep developing it then.